this problem, we're asked to look at this relation, which happens to be a function. It's a relation too. And determine the Y-intercept, the X-intercept, and symmetry. And for symmetry, we want it to know whether it's symmetrical over the X-axis, the Y-axis, or the origin. And we need to do this algebraically. We need to do this with letters. So let's try and get started here. First of all, let me just point out that when you have f of x equals anything, it's essentially the same thing as saying y is equal to x squared plus x minus 6. F of x and y are usually interchangeable. Y, when you use a y, it usually refers to a specific number being put in there, but really they're pretty interchangeable. I prefer the f of x notation. It means more to me. It's a function of x. So when I'm finding the y-intercept, I set x equal to 0. If I kind of look at my little graph here, every single y-intercept that I'm going to have, x is going to be equal to 0. So where x is equal to 0, I'm going to have a y-intercept. All right. Well, let's set x equal to 0. I'm going to have y equals 0 squared plus 0 minus 6. So I can see that my y-intercept, where x is equal to 0, is going to be a negative 6. So I'll just write that in over here. I'll write negative 6, my y-intercept. And really, you should put this as an ordered pair, which would be 0, negative 6. I didn't take off any points for that, and I generally won't, but the intercept is an ordered pair. Okay, so we got that part of it. What about the x-intercept? Well, again, looking at our little graph here, every place I have an x-intercept, every place I might have an x-intercept, my y value is going to be equal to 0. So in order to find the x-intercept, I need to make my y equal to 0. All right, let's do that. 0 is equal to x squared plus x minus 6. Well, let's kind of go back to a little bit of algebra here. The best way to do this problem is to take this part and factor it. So if I have 0 is equal to, and I'll just kind of FOIL this out, x, and looking at this, I can kind of see, well, I need a 3 and a 2, because there's a difference of 1 between those, and it has to end up positive, so positive 3 and a negative 2. So I've now factored this quadratic because it's to the power of 2, into x plus 3 and x minus 2. And that has to be equal to 0. Well, there's two numbers that can make that equal to 0. If x is equal to negative 3, then this will be equal to 0, because this part will be 0, and 0 times anything is going to be 0. Or, excuse me, if x is equal to 2, then this part will be 0. So my answer to this part, my x-intercept, is the set negative 3 and 2, or, better yet, write it as an ordered pair. I would go negative 3, 0, or 2, 0. And there are two answers to this. There isn't just one. It's a quadratic, so I am at the power of 2. It's likely that I'll have two answers. So you have to remember to factor this out. Let's take a look at symmetry. So for x-axis symmetry, what I do is I change y into negative y. For y-axis symmetry, I'm going to turn x into negative x. And for symmetry around the origin, I'm going to turn x and y into negative x and negative y. I do each of those separately, and when I do that, I compare I compare the formula with the negatives to the equation, the original equation, and if they are identical, then I have symmetry. So let's take a look at the x-axis y first. So I'm going to use the y formulation here. So I want to change, I'm looking at this, my original equation, and I'm going to change my y to negative y. Okay, negative y equals x squared plus x minus 6. Well, let's make the y just a regular y and multiply both sides of this by negative 1. And what I get is y equals negative x squared minus x plus 6. And now I take a look at this, and I see, well, is this the same as that? Are these two things equal? Does the y equal the y? And no, they don't. They're not even similar. So the answer is there x-axis symmetry is no. No x-axis symmetry. How about y-axis symmetry? Well, for y-axis symmetry, I need to change my x's to negative x's. Okay, so let's write it down here. I have y equals negative x squared plus negative x minus 6. I'm going to stop right here and say I really strongly encourage you to use parentheses when you're doing this, because negative x squared is not the same thing as negative x squared. If I don't have these parentheses, even though I might get the answer right, and I wasn't too harsh on that, it's wrong, and I will find many mistakes. So if I'm substituting negative x for x, or I'm substituting anything for x, it's really a good idea to at least start by using parentheses. So I use my parentheses here. And now I can see that y equals, with the negative x, y equals x squared, because negative x squared is x squared, minus x minus 6. Well, is this the same as that? No, they're different. So, no, I do not have y-axis symmetry. What about symmetry over the origin? Okay, symmetry over the origin. I'm going to change both my x's and my y's. Go away, please. Both my x's and my y's to negatives. So I'll have negative y equals, again, parentheses, negative x squared plus negative x minus 6. Negative y equals, I'm going to square my negative x, that's going to be x squared minus x minus 6. Well, let's get just a y on the left-hand side. So let's multiply this by negative 1. And we'll get y is equal to, now I have negative x squared plus x plus 6. Is this the same as that? No, they're very different. So the answer to this is no. I do not have symmetry over the origin. I'd like to just comment a little bit on some of the algebra that we were doing, that I saw when we were working on the problem. So here, if you remember, I have y equals, I'm going to factor this out, x plus 3, x minus 2. Well, some people knew that they needed to set, when we're finding the x-intercept, they made y equal to 0. So that was y equal to 0. So that was a good first step there. So they would have 0 equals x squared plus x minus 6. But then, instead of trying to factor this to get this, a number of people added 6 to both sides. So we would have 6 equals x squared plus x. That's going to be difficult to solve. You really need to solve this problem by factoring. And one of the mistakes I saw as people tried to solve this was they divided both sides by x. Now this is going to lead you down the wrong road, but I want to point out something about this part of it right here. This does not equal x squared. What a number of people were thinking was, oh, well, I have x on the bottom, I have x squared over here, I have x over here. Maybe I can just cancel these out. But you can't cancel them out when the top term is joined together with a plus sign. Now, if it was x squared times x over x, yes, then you can cancel it out, and you'd just be left with x squared. But when they're joined by a plus sign, I'm going to try a new description here. I've never tried it before. It's like they're married. And if you're going to divide one of them, you have to divide the other one. So you have to be very careful in doing this. And another way that I describe it, if I say 5 plus 3 divided by 3, well, you can see that that is going to be equal to 8 over 3. But if you do this thing of canceling out the 3's, you're going to wind up with that equal to 5. And this is the right answer. That is the wrong answer. So be careful on your algebra there.